Good morning everyone, welcome back to Dev Parkour. I'm Brian Parks, and in this video I want to talk about why we do security testing, sometimes also called pen testing or penetration testing, specifically with regard to web apps. So this is specifically in the context of the Glassminnow project that I've been working on for several weeks. If you haven't seen any of that, go ahead and check out some of the videos from the last month or so. I'm working on a PHP app, taking it from legacy status. Before I picked it up again, it hadn't been touched in at least 5 years, and turning it into a cloud native app that is scalable, maintainable, and hopefully also secure. So when it comes to security testing, what this ends up looking like is there are some automated tools and there are some manual processes that dedicated pen testing companies will go through to perform a security test on your application or your infrastructure. But they all basically start kind of in the same place. They start with just using your app. So sending normal requests, getting normal responses, and looking at some of the details that come back. So some of the low-hanging fruit includes, what server you're using, because there are potentially published exploits for whatever version of Apache or IIS you're actually using. The cookies that you include in your requests and responses. And then from there, they'll start making modifications to the requests. So they might change your login cookie to something totally different and see what happens. Do you get an error? Do you get a login prompt? Do you get unauthorized status code, an HTTP status code indicating that you're not logged in anymore? Something along those lines. And different things mean different security results. Some might fall into like a warning category. Like if you changed the login token, for instance, to something that didn't exist, and you got a 200 back, that's questionable. That's not necessarily wrong. You might need to do some additional digging to figure out, are you exposing anything sensitive in response to that. And then there are some that are fairly well documented, not necessarily exploits, but vulnerabilities at least. And either next week or the week after, I'll talk about some of them specifically. But for a general overview, you can find the OWASP, that's OWASP, the Open Web Application Security Project. They publish a top 10 list, the top 10 most prevalent vulnerabilities in web applications. They update it every 3 years-ish, I think. I forget when the most recent one came out. I want to say 2017, but there might be one more recent than that. But go ahead and check that out. That lists all of them. Really good, really informative. And they do a really good job in explaining it in ways that programmers, who are honestly the people who have the most impact, the most direct impact and direct potential to change these things in the code. But unfortunately, not all developers go through application security training, which is a major bummer. If you're interested in that, I'd be happy to do more videos on that. I've gone through a couple trainings myself. I find them really valuable. It helps me approach code a different way. That definitely, it puts security first, and I think that's really important, especially in 2021. So leave a comment down below if you want me to go into that. So getting back on track, why do we do security testing? Well, aside from the fact that security is good, we want to be addressing security. The reason we do security testing is specifically to make sure that we're not exposing those vulnerabilities, both to protect the infrastructure that our app is running on, so that ideally that infrastructure can't get hacked, so that the app itself can't get hacked, or make it as difficult as possible to do that, so that we're not exposing any data we shouldn't be. And especially if you want to go the SaaS direction, now it's not just about you, it's about your customers, your users, maybe your customers' users, you're dealing with the information of people you've never met, you've never talked to, and that's really important to keep safe. So some customers might even flat out ask you, do you have a pen test report? Or they might pen test your application without even telling you. That's the other end of the spectrum. Hopefully they do tell you, so that you can make sure that they have their setup configured in the most secure fashion. Ideally, you don't do anything that is insecure by default, but at the same time, it's not uncommon for people to stand up test instances and, for instance, not set up an SSL certificate. These days it's super simple to use an SSL certificate on a web app, but some people might not, and that's an obvious low-hanging fruit. That's 100% of the time gonna get flagged by a pen test. It's going to say, you are not running on SSL. What are you doing wrong? And when I'm going to run a pen test against Glassminnow, but I'm going to be running it locally, and I'm not going to be using an SSL certificate. So you'll see right off the bat, vulnerability number one is going to be, this app should be running on SSL. So, you'll want to make sure that your app is configured with security in mind. Configuration, the actual application code, the infrastructure, but then it also carries into some architectural decisions. A big one, and one vulnerability that's probably very familiar to most people is something called Sql injection. These days it's actually lumped into a larger category of just injection, because there are a lot of interpreted things that could be injected, JavaScript, expressions if your system does some sort of expression parsing, SQL, and several other categories that are slipping my mind right now. But anyway, SQL injection, right? This is basically if you have, let's just take a login form, enter your username and password. If you are manually constructing the SQL on the back end, select star from users, where username equals plus the value of the username field plus, and password equals, and so on and so forth. That's an opportunity for SQL injection, because now I can type in, some arbitrary SQL into that field, and because I'm just concatenating a bunch of strings together, there's no validation on what I've typed in. And there's nothing preventing me from typing SQL, and B, there's no distinction in that SQL statement between the query itself and the data that's being used for the query. So, really quick, the two defenses against SQL injection are: one, don't do string concatenation to build your SQL queries, and two, treat data as data. Always treat data as data. Never treat data as something that might be part of a query or something like that. So most languages, most database driver libraries have some sort of functionality for either something called prepared statements, or at least parameterized queries. So you write the query with some placeholders where the actual data is going to go, and then through some object-oriented interface or something along those lines, you specifically say, well, this placeholder should have this data. And what actually happens behind the scenes, you don't see this, you don't have to worry about this, but the query gets sent to the database server first, and then the next packet essentially is data placeholder 1 is this value, and then data placeholder 2 is this other value, and so on and so forth. So they are actually completely separated. They are two different pieces, and the database server knows that one is a query and one is, it could be complete garbage, it could be very dangerous things, but because it knows never to treat it as anything other than unsafe, untrusted data, it will never try to execute it as if it were a query. So that's kind of a long-winded deep dive into Sql injection. So I can check that one off the list for next week or the week after, and talk about some others. But that's kind of an easy one to think about in terms of vulnerabilities, especially as they potentially influence your architectural decisions. So the interest of avoiding Sql injection might drive you to choose a particular ORM, one ORM over another. And in fact, I think, let's see, possibly tomorrow's video, I'm going to talk about what I'm going to do for an ORM in Glassminnow, and that is exactly why I chose the ORM that I did. So stay tuned for that. Be sure to subscribe. Click that notification bell so that you'll be notified tomorrow when I post the video about what ORM I'm going to use for Glassminnow. I'm excited for that. I hope you are too. So we've got security vulnerabilities because we want to keep our infrastructure safe. We want to keep our customers, potentially infrastructure if we do on-prem, but at least data safe. We want to keep their customers' data safe if our tool is used in that way. And then we want to potentially influence architectural decisions by placing security first, so that we don't have to tack on security at the end. Because, and this is super important, so I hope you got to this point in the video, security is not a feature. Let me say that again. Security is not a feature. What I mean by that is you can't take an application, or you shouldn't. You can, but it's hard and painful, and you shouldn't do it. You should always place security first. But it's painful to take an application and say, okay, let's make this secure. Now, that is what we're doing with Glassminnow, because at the end of the day, if you have an application and it's never been security tested or anything like that, got to start somewhere. So we'll do some security testing. We'll make this application secure. I'll show you what that's like, and I'll show you kind of some of the changes that I'm making. I will kind of hide some of the pain because, we don't have hours and hours on video together, but that's what we're going to do. So I recommend putting security first, thinking about security at design time, at architecture time, so that as you're building something out to begin with, you have security in place. So I'll leave you with that. If you enjoyed this video, be sure to hit that thumbs up button, subscribe, click that notification bell, and leave a comment down below. Comments, questions, they're all welcome. And I will see you tomorrow.